So it's my pleasure to introduce all the speakers, but really a special pleasure for me to introduce Zaki because he was present at the beginning, at the very first meeting we had at TRI when we began brainstorming about how blockchains and mobility might be interesting. And Zaki has been at the forefront of this for many years. He worked at SKU-Chain in one of the early supply chain management projects. He's been working in Cosmos and Tendermint and really at the cutting edge of this, as well as his current role as executive director of the Trusted IoT Alliance. Cool. Zaki, thank you.
Yes. So I suspect that some of you are not familiar with the Trusted IoT Alliance, and I'm not going to go into great detail about what the Alliance is, how we work, all that stuff. This isn't really a Trusted IoT Alliance pitch conversation, though it does pose a problem that I think we could work on together. If you'd like more information on the Trusted IoT Alliance, just talk to me afterwards. I'll be around for today and tomorrow, so you'll have plenty of time to hit me up for what is the Trusted IoT Alliance. But my point of view of there's always been a deep synergy between the vision of MOBI and the sort of the conditions that led to the formation of the Trusted IoT Alliance, the work we're doing, and the potential that I see in the Trusted IoT Alliance. So let's just talk a little bit about what we want is emergent behavior. What the entire idea of using blockchains, of using permissionless systems, of thinking about the future of mobility as an interaction of these systems is we want developers to come up, developers, startup companies, ecosystem participants, to come into these ecosystems, see all the pieces that we've added to them, and then come up with something new that makes a whole that's greater than the sum of the parts. That is the vision. That's like why it's largely the entire purpose, the entire reason of building blockchains. We can accomplish integration, data exchange, et cetera, with legacy IT systems. What legacy IT systems have never been able to provide us is that environment where someone new can show up, innovate on top of the system, and then entirely new behaviors can emerge. And I'm reminded by this experience. So in 2014, we had this conference at SKU-Chain called Crypto Economicon. Crypto Economicon was kind of like, it was even lower key than this conference. But it was like, Vitalik was there. Vitalik was like 20 at the time. There was, Ethereum hadn't come out yet. Vlad Zamfir was there, who's a proof of stake researcher. I think he pretty much discovered proof of stake at that conference. Martin Kopelman, who runs Gnosis, Jaquan and Ethan from Cosmos met each other at that conference. So it was hugely formative. And we had all these ideas, like what would people do with a programmable system if we built one? And Ethereum was like one of the designs that we were talking about. And so we hypothesized about, maybe people will build stablecoins. So now 1% of Ether is in a stablecoin called MakerDAO. We thought people might do ICOs. We'd seen a couple of sort of cycles of the ICO boom, and then 2017 was ridiculous. So the desire for building on top of these open platforms is emergent behavior. But there's a problem here. So there's a problem with getting to emergent behavior. And the problem with getting emergent behavior that the people in this room are uniquely situated is there is one thing that cannot emerge as emergent behavior. And that is the root of trust in the system. The trust that exists that if a car is part of a distributed ledger and commits to doing some action, to collecting some data, or attests that that data has been collected in an authentic way, or commits to the idea that it will not drive unless the driver can present proof of insurance. If we do not have that bedrock of trust in the system, none of these emergent behaviors can emerge. And what I would advocate that we all do, if we see this goal of immense value creation from ad hoc emergent behavior, to focus on establishing the foundation, because that will take some degree of political, financial capital, long-term planning, and things that don't just magically appear when the conditions are right. So I would say that the reason why why did we not call it the IoT Blockchain Alliance or any of the other things we called it the Trusted IoT Alliance. So there's this notion of the trusted computing base, which is the minimum characteristics that a computing system must have before anyone can trust it. And so the TCB shall maintain a domain of its own execution that protects it from external interference or tampering. Resources controlled by the TCB must be defined as a subset of the subjects and objects in the, I don't remember what ADP stands for, but, and the TCB shall isolate the resources to be protected so they are subject to access control and auditing requirements. So this is from a book that came out in 1985 from the Department of Defense called doesn't really matter what you call it. Everybody calls it the Orange Book. It's sort of like a foundational piece of literature in computer security. And what I would argue is that for the most part, while the Internet of Things is not part of the trusted computing base. We have computers in them. We put computers in all kinds of things. There's like computers controlling our AC. There's computers controlling the lights. There's computers all throughout our environment. But for the most part, those computers cannot be considered trusted. And so the vision of the Trusted IoT Alliance, to a certain extent, was to try to accelerate the technical, economic, use case conditions for a trusted computing base to emerge for the Internet of Things. And you've started to see this. California just passed its first regulation for Internet of Things a few months, like less than a month ago, maybe last week. You've had earlier in the year, I was testifying for the European Council about their ideas for IoT device regulation. We see this desire as an industry to sort of bring the Internet of Things into the trusted computing base. And what I would say is that what people in this room need to think a lot about is how we're going to bring mobility into the trusted computing base. So we talked, we've just been talking about grand challenges, and we have a 3-month grand challenge. But I would say as an industry, we probably have a 5-year grand challenge to deploy into the automotive supply chain a TCB, a trusted computing base. And if we're going to have complex logic, it'll be driven by feedback mechanisms, and the feedback mechanisms will be provided by the TCB. So just sort of an example, it's like, if this data from this route, you've got a car driving through the world, is worth 5 cents to a machine by a certified vehicle with level 4 autonomous driving sensors, then what do you need? You need proof of the vehicle's origin and technical capabilities. You need a proof of location that it was actually there. And you need proof of maintenance and recertification of all of its systems. All of those things are going to be an interplay between a distributed ledger system and some sort of secure computing device that is in the vehicle. So I apologize for the Tesla for the people in the room, but it was a nice diagram. This has kind of been done by the automotive industry already, which is they have done the VIN thing. And what I think that is, and a VIN is like is a good example of what you would try to do if you wanted to do an immutable physical identity, which is you have the same identity in multiple places in the vehicle such that it is virtually impossible to only replace one piece. So imagine if the VIN was just a sticker. So then someone take off the sticker, you produce a fraudulent sticker, you put another sticker on, now it's got a new VIN, your car has a new identity. You completely defeated the purpose. But the idea has been that if you have the VIN in enough places in the car, that it is unlikely to have a still functioning car that appears to have a consistent VIN that is different from what it was manufactured with. So that's awesome, but why does a VIN not solve our problem? Our problem is that we need remotely attestable data. that you don't want to go when you go and you buy all of the data that has come off of a car as a company that's trying to train its machine learning algorithm. You don't want to send a mechanic out to go check whether or not that vehicle is the same vehicle that rolled off the factory floor. You want to be able to remotely attest that data. So can this be done? It certainly sounds hard and scary. And I'm going to make it seem harder and scary before we're done. But I would also like to observe to everyone that this has been done, and it has been done by Apple for the iPhone. Every iPhone has what is called a secure enclave in it. It is a separate microprocessor that provides the trusted computing base for the iPhone. They have deployed essentially 1 billion devices with these in it. And every one of those devices has a persistent identity that is created in the factory, only exists within the device, and is immutable for the history of the device. So this, I think, technologically, we can look at the iPhone and say, this can be done. You just simply have to want it. It has to, the economic incentive to create it has to be high enough. And Apple has felt that the security and privacy benefits of making every Apple iPhone a trusted computer outweighed whatever the sort of immense technological feat of creating the secure enclave. So there are a bunch of technologies that are sort of relevant to this. Intel has their enclave technology called SGX. There's an emerging open source movement around an instruction set called RISC-V, and lots of investment, interest. I know somewhat through the grapevine that NVIDIA is building a secure enclave based on RISC-V, specifically targeting the mobility sector. So there's action going on there. And they're sort of, both of these technologies are sort of subsets of the general idea of called a trusted execution environment. And for the vision that MOBI is trying to accomplish, I would say that there is no doubt in my mind that if we do not put a trusted execution environment, we do not make a plan that at the end of that plan, there is a trusted execution environment in every automobile, we will not be able to get to all of the other potential that we see. So I made I think an argument for possibility. I also want to keep you an eye on the need to change this and the difficulty of making safe choices. These are 2 attacks from the last 6 months that enabled stealing private keys. And when we say a car must have an identity, what we really mean is it must have a private key that never leaves the vehicle. And this is an example of 2 attacks, both on, that attack, the Roca attack, resulted in a situation where the ID cards that several EU countries use, including Estonia, for things like voting, the private keys were extractable. And this was called the foreshadow attack, which has been part of a general theme of attacks on Intel computing, on sort of Intel's secure execution technology that also resulted in the ability to extract the key. So the challenge of this is going to be, not only must we kind of have to pick some technologies and come up with some plan that results in it being part of the automotive supply chain, we might have to upgrade, change, patch these technologies in the field according to some sort of sane way, because building secure computers is on the whole something that the computer industry has no idea, well, I wouldn't say no idea, just doesn't know how to do yet. And we're kind of in a period where the state of the art is rapidly evolving. So what I would sort of propose is that we as a group think of this as a 3-phase process, but I would strongly recommend that we do not view this as something that we do phase 1, complete it, then do phase 2, then do phase 3. I think I think phase 1 could be done now, phase 2 will take several years, and phase 3 is more like the 5 to 10 year horizon, so we should probably start all of them now. So phase one is, a device. John's not here anymore. I think he had to leave. But Oaken makes a device for that provides sort of a trusted execution environment of a sort in an ODB board device. You can imagine we are putting fancy computers and fancy user interfaces in most new automobiles. So you can imagine a world in which a cryptographic identity was provisioned in a single place. And then phase three would be a remotely attestable idea or remotely attestable identity that is truly immutable. That if for that identity to be changed, the car itself would effectively have to be destroyed. So those are my ideas. And I didn't want to sort of focus this as a sales pitch for the Trusted IoT Alliance, but my sort of my pitch to you guys is I think this is something that the Trusted IoT Alliance and MOBI should work very closely together on. And my argument for doing that is that I don't believe that, especially when it comes to the phase two and phase three solutions, that it will be mobility sort of specific. I suspect that what will happen is that we will see a solution that is sort of cross the entire sort of edge compute IoT industry, that will have a specific instantiation and be implemented in a specific way by automotive OEMs. But like the general theme of where do keys get provisioned, what kinds of keys do we use, what are the bits and pieces of an identity, what are the sort of minimum viable security, will be best sort of executed as an entire IoT industry-wide thing. So that's my pitch to the members of MOBI, is that the Trusted IoT Alliance and MOBI should work together. This is the mobility use cases are an incredibly compelling use case for deploying a secure computing-based identity to these computers that we have driving around, flying above us, incorporated in our buildings. But ideally, we need a solution that sort of an entire industry can adopt. So that's my talk. I was probably pretty fast, but I'd like to have questions. So plenty of time. And also, as I may have mentioned, I'm an expert on security, distributed computing, all these things. So if you want to go off topic, go ahead. Any questions?
So the physical chipset, the idea of having that trusted computing platform,
Yep.
is a prerequisite, in your opinion, to having true vehicle identity in a car. You need
Yes.
you need that as an independent component.
That is my point of view.
Yeah.
That's, if you sort of look, this is what my argument is. This is the only example that we have in the world of large-scale consumer deployed trusted computing. It's the only example that exists. How did they do it? They made a specific subcomponent on the bill of materials called the Secure Enclave, and they put it in every iPhone. Mm-hmm. And that was the solution. And based on that example, which is the only successful example that exists in the world, I argue that we should emulate it.
In the automotive space, there's a few like head unit providers.
Yep.
Alphabet, Apple, the automotive grade Linux teams and so forth. Would it be equally feasible to have a software form of that in those platforms?
So
if they all three adopt it, if you will.
it would get you to the phase 2 solution, which I think is a huge step forward. Like, phase 1 gets you to field trials.
Sure.
And like early consumer adoption. Phase 2 gets you to an economy. Mm-hmm. Phase 3 gets you to the world runs this way now. That's kind of the way you want to think about it, in my mind. And so we can attack phase 2 through the head unit manufacturers and the willingness of and as far as I can tell, there is this movement, and I see bits and pieces of these things moving around that in like parts of the industry that I watch that strongly imply trusted computing is coming to mobility. Like, I know there's a huge team at Baidu that is working on SGX-based technology for the mobility sector. I know about this team at NVIDIA that is building a RISC-V-based enclave. I don't have NDAs with any of these people. I just know these things. I know these things are coming. I think that it's such a key enabling technology to everything else, because this is what I'm saying is this can't happen in an ad hoc ground up manner. Somebody has to decide to put the chips in the car. Once you have the chips in the car, what they're used for can happen organically.
Sure. So MOBI's role in this idea of maybe picking the winners in that, I don't know.
Yeah.
Or determining whether you need a discrete computing platform, trusted computing platform that's independent of the head unit, or any of those kinds of things. Is that a responsibility that MOBI should take on?
It's what I think you should take on. Yeah. I think picking a winner, and I think moving fast here, because the rest of these things will not move fast, no matter how hard you try. And I think that's a huge value proposition. But I would encourage everybody to sort of think through what is the likelihood that one of the 10 use cases that you have is a multi-billion-dollar opportunity for your companies. And if that is, then if any one use case is a multi-billion-dollar opportunity, then starting now is probably worth it.
So just to add the concept of creating the keys in hardware is ubiquitous across industries. That's a problem that we're seeing. There's a lot of movement already going with identity solutions with software-based keys, but I think that the idea is later on that they would be replaced with some sort of firmware solution that would generate the keys. So my question was actually on number 3, the immutable mobile identity. You know, this is one of the things that in the identity working group that we've encountered. You know, it's an edge case, but it's where they I forget the industry term for it, where they take a wrecked car and they rebuild it out of other pieces.
Yeah.
So in your scenario, this third case, is there any recovery mechanism, or do you envision there being a recovery mechanism for compromised keys or lost keys within firmware? And have you heard of anybody that's working on that?
So my experience as a security person is that key reprovisioning is the hardest problem. The easiest solution is not to do it. Is to
So destroy the car and start over?
Well, or if the car is destroyed, it's sort of lost to, because we're never going to get to a world where 100% of the cars on the road have a trusted computing base inside of them. Like, that world is because the cars that are currently on the road will be on the road for 20 to 40 years. So there's no world in which you have 100% coverage. So losing a vehicle to that world will probably not be the end of the world. It's just simply it doesn't make the vehicle useless, but it may reduce the ability of that vehicle and the value that vehicle has in terms of its ability to participate in sort of this distributed economy that we're all trying to envision.
Yeah, but some aspects of that is distributed economy are based on reputation.
Yeah.
So it isn't just that the vehicle has an identity that is valid and hasn't been compromised. A lot of it has to do with the fact that that vehicle has a reputation for behaving in traffic in a normal way.
Yep.
And so that's less about, I guess compromised identities come into that, and that someone can spoof a vehicle then. So I'm not sure.
I mean, I think the thing that really sort of causes a massive amount of leakage in this world that we're trying to talk about, a loss of potential economic value, is if it appears to be feasible to steal an identity. If an identity can be moved invisibly and undetectably between artifacts in this system, the amount of economic value you give up is immense. And so it's sort of an interesting trade-off between having some way of taking a car that was, really smashed up and reassembling some components of it into a new working vehicle versus the potential economic loss of lack of trust in sort of an entire system because it turns out an identity is more portable than intended.
Well, an example of this issue about changing identities is when we get to a world where road use charges or air traffic controllers or direct impact based upon environmental impact is based upon the vehicle's identity, you could imagine somebody wanting to alter the identity of their vehicle to be one that doesn't cost a lot to operate.
Exactly.
When in fact the vehicle
Costs a lot
otherwise
to
hasn't
operate.
changed. Right.
Or has a lot of negative externalities.
Exactly, right. So this is a big deal.
Yeah. I mean, but, it's like that simple example. Think about how much value is unlocked if there's a significant subset of the cars that can seamlessly attest their environmental footprint. That is extremely large number. And you don't need to incorporate that into any of this. That's just an emergent behavior on top of assume this exists.
So Zaki, I have a question about components.
Yeah.
So somebody was describing that today the odometer reading is stored in the transmission computer, the head unit, the ECU for the engine. It's like in 3 different places. So
Yep.
they can all agree this is the odometer reading. And so we got by the way, this is exactly what we do in the working groups. We have this exact conversation going on. I think we had it this last week, right? With somebody presenting on this topic. But so my question is, in this, are you talking about discrete computing platform, trusted computing platforms for each component, like the transmission, the engine? I remember you, Nick, talking about somebody in a card sharing service taking the engine out. I use that example all the time now, where somebody, all of us share a car. I got it one day and I said, that's a really great engine. I'm going to take it out and put it in my Datsun, right? And then put my Datsun engine in. I love Datsun 510s, by the way, if you've ever had one. Anyways, but take that Z06 engine out and put something else in its place, right? So are you advocating for discrete, isolated, trusted computing platforms on each component, or one that is tied to the chassis? What is it that, how does this work out?
So what I would imagine is that if we were to get to phase 3, we would get to discrete trusted computing components on individual components of the system. But that doesn't mean that you can't change one of them, because the wonderful thing about global consensus ledgers is that the other components of the car could potentially authorize changing one component of the car and say we are still substantively the same car.
In fact, recalls and repairs and maintenance would.
I don't think any of
require
that is actually that hard in this world. I think the hardest part of this world is spawning that identity in the factory.
In getting the cost of the chipset down to 0.00001 cent.
Yeah, absolutely. Well, and so this is kind of the interesting thing about why the Trusted IoT Alliance kind of feels like it needs to exist is we're never if this trusted computing system is perceived to be low economic value, then we really have to push the cost of components to nothing. It's really not about some sort of absolute floor on the trusted computer. It's how much value it provides to us at some point.
Yeah, I agree, but you should work with the procurement departments in these OEMs. They're kind of tough. So anyways.
I mean, I'm sure Apple's procurement department is just as bad.
Dave, you made a comment on advising for the MOBI challenge that everybody use hardware-generated keys. And I mean, was that what you were saying? I think
Not for the MOBI challenge.
Okay,
I was asking more
'cause I
about
think
on our
it's
standards.
It's a bit of a stretch to say just because we all agree that hardware-generated keys are the only safe way to go, that for the MOBI challenge we can't use alternatives.
It'll probably be really good for Oaken. I'm just saying.
Our riddling code and our few
advantage.
folks. Yeah. Maybe it'd be interesting to see both models employed in the MOBI challenge and kind of understand the implications of both.
But yeah, I mean, I think the MOBI challenge, there are products on the market right now that will do phase 1.
So you mentioned Apple and SGX and
Yes.
the other work on RISC-V, trusted execution environments. Do you see this at this point then as a technology challenge or a pure business challenge, just convincing these companies to do this?
There are clearly technology challenges. I wouldn't say that, if there was some no-brainer technical approach, this would be far easier. There is risk in in all possible sets of technical approaches, like Apple's solution was really good, but is also in-house and will only manifest probably in a car if Apple makes the car. But I also know that if Apple does make a car, there will be a TCB in that car, because that's just how they think about the world. And I think they've seen how much economic value was unlocked by having the iPhone as a trusted computer. But it's the business challenges probably with the right forethought can run in parallel to the technology challenges. Like you can have something something that fills this space, convince the supply chain and the procurement system that we need that this is a requirement that we have to fulfill this space, and then fill that space based on what appears to be attractive a year or two from now. Okay. Anything else? Chris? And there was another.
You said you weren't going to talk about the Trusted IoT Alliance, but I actually want you to.
Okay.
Give a quick introduction to them, who the founding members were, what their objectives were. And in particular, you recently had a meeting where you talked about an alliance with MOBI.
Yep.
So can you give us a little bit of the flavor of that discussion? What would you like to see?
Well, so in terms of the alliance with MOBI, this is what we talked about, is as what we would start out with as a point of collaboration. But let's talk a little bit about what the Trusted IoT Alliance is. The Trusted IoT Alliance was formed so the IoT blockchain narrative, which to summarize it concretely is blockchains are an internet of assets. They are the first system of robust digital property rights that we've ever had. Property rights are frequently applied to things in the real world. So there's this natural sense that one of the biggest industry adoption challenges that the IoT space has faced is that IoT devices only sort of today really work inside of some company's silo. So everything that is on this Hyatt property lives within the Hyatt IT silo and was provisioned by the Hyatt IT silo and is owned by the Hyatt IT silo. And that's great. But when you as a customer of Hyatt walk into this and you have your iPhone and your iPad, and in the future, hundreds of devices potentially will walk in with you. Right now, there's this out-of-band process of convincing the Hyatt IT system to trust your devices, that you are legitimately the devices of a customer of Hyatt, where you enter this your name and room number, and this happens. And this is not a scalable solution. So in 2016, myself and when I was at SkuChain, and Ryan Orr, who was at Chronicle, who was doing this sort of device identity thing way before, like super early, started in 2014, started seeing like all these people coming to us wanting to do proofs of concept, et cetera. We didn't see that it was obviously monetizable by our startups. So what we thought was the right thing to do was create a network. And so we got about 40 different companies together in a house in Berkeley in the winter of 2016. And sort of from those people, Bosch, Cisco, Gemalto, BNY Mellon stepped up and wanted to say, okay, let's build an industry consortium. we're different than MOBI. We do not necessarily have the clarity of mission and purpose that MOBI has. We do have a very broad mandate to help this industry evolve. And what we saw in 2017 was sort of an as we sort of got everything going, was an unexpected surge of new ventures. And so in a lot of ways, all of these new ventures that got started up absorbed a lot of our bandwidth in 2017, just onboarding them, figuring out what they did, figuring out what they needed. And so right now, what the Trusted IoT Alliance is mostly focused on from its members' point of view is assisting them with commercialization. We have a membership that has sort of about 8 large companies and about 50 startup companies of various size, scales, funding levels, tokens, no tokens. But they've all bought into this vision of blockchain as a solution to IoT, but there is something of an open question about where initial commercialization, where large-scale commercial adoption will occur. And so the focus of right now the Alliance is probably for sort of the remainder of 2018 and early 2019 is really sort of trying to help our members and the industry as a whole figure this out.
Great. Thank you, Zaki. Perfect. I think we're right on time. Thank you. That was great.